Morning. My name is Brian Dean Abramson. I am the chair of the National Vaccine Law Conference and the author of the legal treatise Vaccine, Vaccination, and Immunization Law. I am also an adjunct professor of vaccine law at the Florida International University College of Law. Today, we celebrate World Vaccine Day. May 14th is the 227th anniversary of Dr. Edward Jenner's first successful of the smallpox vaccine. And I would like to thank Jim Scherer for inviting me to be a part of this day and give you a brief presentation of what vaccine law addresses. So, a lot of people have asked me why I became a professor of vaccine law and an author of a legal treatise on vaccine law. Vaccine law is a confluence of many different areas of law. There are laws regulating the licensure of vaccines. There are patent cases regulating intellectual property protection for vaccine inventions, and there is an entire system set up for compensating the very rare occurrence of vaccine injuries. Vaccines were in the news frequently, even before COVID-19. There were circumstances with influenza deaths that could have been prevented with vaccination. And it is a field of law that I think is broad enough to support its own area of legal study. Ultimately, what vaccine law is all about is the public policy focus on preventing the spread of contagious disease and thereby saving lives. So, what is a vaccine? Well, the Milky Way has over 200 billion stars. You may wonder, why am I telling you this? Because the human body has over 30 trillion cells. That's 1,500 cells in your body for every star there is in the Milky Way. And remarkably, are probably an even larger number of microorganisms living in the body. Most of these are gut bacteria. We also have different kinds of bacteria and other organisms that live in our skin, in our nasal passages, in our lungs. Most of these are harmless, and some are even helpful to the body in its processes. But there are some that do cause harm. And when they cause harm, it can be even serious and lead to death if it's the wrong kind of microorganism. So the body has a natural defense against this. Here you can see a white blood cell chasing down a bacteria, enveloping it, and ultimately devouring it. And you may wonder, how does that cell know to go after that bacteria? Well, there's a thing called reactive immune system. Now, in ancient times, it was understood that people who survived a plague were less likely to get sick the next time that that plague came around. And this was generally attributed to the idea that the gods took pity on them, and for their having suffered from the plague before, they were spared the next time. Now, I often ask in my class, who here has been exposed to measles in their lifetime? That's kind of a trick question, because most people at some point in their life will be exposed to measles, especially if they travel abroad to countries where measles is endemic. But all of us just about have been vaccinated for measles. So when we're exposed to it, the virus attempts to enter our body, but our immune system does what that white blood cell did in the earlier illustration and envelops and destroys it. Now, thousands of years ago, people didn't know this was happening, uh, but smallpox has been a disease that has been a scourge of humanity, or had been a scourge of humanity, for many thousands of years. So at some point, it was discovered that if you took the pustule from a person who had been infected with smallpox, ground them up, and either introduced them to someone's skin or turned them into a powder and blew them up someone's nose, that person would become somewhat ill, but then recover, and then have a greater chance of immunity to smallpox if they were actually exposed to the disease. This was called variolation. And variolation was also discovered in Africa. The illustration that I showed you on the previous screen was from in China, where this was practiced 1,000 years ago. Variolation was also discovered in Africa, and from Africa, it was introduced to the United States in the early 1700s. Um, Variolation did carry some risks, but during the American Revolutionary War, General at that time, George Washington, found it necessary to have the troops at Valley Forge variolated for smallpox because the British troops were, and the American troops would be at a disadvantage if they would be subject to being infected with smallpox and possibly dying from it, while the British troops were protected from that. Some 20 years later, Dr. Edward Jenner, who we mentioned earlier, uh, there's a story that he overheard some milkmaids, one saying to the other that she had had cowpox, and because she had cowpox, she would never have the ugly scars that come with smallpox for a survivor. Jenner concluded that exposure to cowpox did something to the body that caused it to develop an immunity to smallpox. So he came up with a process which he called vaccination, because vaca means cow, where he would intentionally introduce smallpox to a test subject and then determine if that test subject had become immune to smallpox. The test subject in this case was the 8-year-old son of his gardener. Now, this was a very different time from today. There was no control group, there was no regulation, there was no um, clinical study that was performed. Edward Jenner performed an experiment on a single child, exposing that child to cowpox, waiting for the child to have that infection, recover from it, and then exposing the child to smallpox, which is known to be a deadly disease, um, and observing that the child uh, was clearly immunized against smallpox. And that is the birth of the entire principle of vaccination, the idea that if you introduce a very tiny amount of something that is less harmful than the actual disease to the body, that will cause the body to develop the defenses that will protect the person from the disease itself, that will cause the white blood cell to go after it like it went after that bacteria. So when an infection gets into your body, it causes damage to your cells. And this damage releases chemicals that are detected by particles that float around in your bloodstream looking for signs of cell death. And when they find it, they go around and they feel in the area. They literally feel the surface of whatever it is that's causing that problem. So if you have a bacteria or a virus that is causing damage to cells, they'll feel that virus and they'll say, well, this is what the chemical surface of it feels like. And they will cause the body to generate something that will stick to that virus so that the white blood cells know to go after it and eat it before it does any more harm. Now, interestingly, this technology has been around since Edward Jenner's discovery in 1796. In the early 1800s, it became very widespread. Countries around the world understood that smallpox vaccination would prevent the scourge of smallpox. And other vaccines were developed for other diseases. One of them was diphtheria. Um, Now, it was also discovered that you could create a diphtheria antitoxin. That chemical that sticks to the diphtheria, which is a bacteria, which sticks to the surface of the organism and tells your white blood cells to go after it, that could be cultivated in another animal and injected into the body. So they did this in the United States. In 1901, however, a retired milk horse named Jim was being used as a host body for the cultivation of doses of this diphtheria antitoxin, which were distributed to children. And there was a tragedy. Jim became infected with tetanus. And thereafter, those samples of the diphtheria antitoxin cultivated from Jim's blood had tetanus, and 13 children died from that. And that event spurred the development of the modern regime of pharmaceutical regulation and licensure, where we have a federal agency that oversees all pharmaceutical products that are sold and marketed in the United States and determines through clinical trials or examination of clinical trial data that they are safe for use for the population and that they are effective for the purpose for which they are sold. That began with something that's an analog to vaccines and carried on for all the vaccines that have been invented in the past century and a quarter since then. So that is an overview of vaccine law, and it's something that's learn about on today, May 14th, World Vaccine Day. My name is Brian Dean Abramson, and please feel free to contact me if you have any questions, and thank you for your time.